chemical reaction to occur without itself being chemically changed. There is an enzyme that makes every process in our body happen. If we're missing that enzyme, we cannot accomplish that process, and most likely will not be here right now. Okay, gotta choose your parents carefully. Here's just some examples of, there's zillions of enzymes in the body. We'll be looking at a lot of them, especially in digestion. Okay, rattlesnake venom contains some really insidious enzymes that destroy lipid bilayers, thus destroying tissue, basically. There's an enzyme for every biochemical process in our body. Okay, next. Okay, and they have very specific secondary and tertiary structures. Okay, and their catalytic activity has everything to do with their shape. Okay, if you even look at one of these things sideways, it'll change its shape and thus lose its enzymatic activity. That's one of the reasons we have such a narrow pH range in which we can live and such a narrow temperature range in which we can live, is because it changes the shape. You change those two things, it changes the shape of our enzymes. Okay, so you don't want to do that. Here we show, okay, deactivating the enzyme, not good. Couple slides on DNA, just look at the pretty pictures. It's a double helix held together by, guess what? Hydrogen bonding. Okay, hydrogen bonding between OH and NH bonds on adjacent strands, and there the dotted line is actually the hydrogen bonding. Okay. So a little bit about acidity, just hydrogen ion concentration varies over a huge range, so we express it logarithmically using the pH scale. A little p means minus the logarithm of. And so there we see some pH of neutral water is 7. Okay. pH of stomach contents is about 2, which is incredibly nasty. pH of oven cleaner is about 13. pH of household ammonia is about 11. And there's the pH scale again. Okay, we have a pH meter, I think we do in the stockroom. I'm not sure we do actually, I forget. But they're kind of a pain because you have to keep them constantly calibrated. A buffer system is a system that's resistant to changes in pH. So that bicarbonate buffer system, we can manipulate that by shifting it to the right or the left, by changing our breathing rate. And that's one of the ways we maintain a constant pH, is by changing our breathing rate and shifting that equilibrium back and forth. Okay, you see why that's so important? You can make a buffer system, you can buy them and just dissolve this powder in a liquid, and you'll have a buffer system at a particular pH, but we can regulate ours and manipulate it. It's much cooler. And I believe that's all. Let's have a hand for the projection.
Yeah.
Yay!
Are you gonna post the answers to your sample quiz before the?
Oh, they just ask me in class.
Well,
Yeah.
I got one.